Can't show you there.
Hi, Jan, I'm here.
Okay.
So I'm going to log out and I want to see if it kicks. I don't think it kicks anyone out, but I just want to try that, right?
Okay.
Okay, that worked.
Yeah, you're back.
How do I make you the host so that I can, because I might go and do some work now, other work at the moment. The way to make your call, okay. There you go. Then shall we start?
Indeed, I see it's 2 o'clock on the dot.
Cool. You go ahead. Thanks,
Okay,
everyone. Okay, I guess welcome back, everyone. I'm going to give it straight to Jan to start. I don't have much to say. I think Jan has a lot more to say than I do. So go ahead, Jan.
Thank you, Kancho. Okay, I wonder if everyone can see my screen now. Anyone give me some indication?
I can see it.
Everyone can see.
Yeah.
Great stuff. And let's go. Welcome, everyone, to this first afternoon session. This is data science is indeed a marathon and not a sprint race. So we started slow, and when we want to pick up the pace, we'll pick up the pace, and when we need to slow down, we'll slow down. I was just watching an interesting YouTube video just beforehand, and a data scientist, and she was saying when she first picked up data science, and she also teaches data science, how to motivate people to to put their money where their mouths are, and she's saying, she said a very valid thing, and she said, start with a minimal amount, get some information about how to code, and start your own little project and just do it. And it won't be perfect, and it will probably not be very meaningful, but it's just that idea of starting to write some code, or starting to analyze some data, or just work with a bit of data. And that is really where it starts, because once you do that, you start thinking, well, I want to do that as well. How do I do that? And you find out how you do that. And all of that just becomes part of your, of the knowledge in your head. And before you know it, you become quite an expert at this. I always like to say, and I think most of you have heard this, the 4 levels of knowledge, where first you are unconsciously incompetent, that you don't even know that you don't know. There are some subjects in this world that I know nothing about, and I don't even know that I don't know, because I have no clue that it exists. And then you hear it for the first time, and you become consciously incompetent. You know about it now, but you're not going to pass your exams with that bit of knowledge, but you know that it exists. And for those of you who are doing exams, not that I always agree with the concept of exams, but anyway, you get to this level of conscious competence. You know it, but you have to think about it. And it's sort of that level that you're at. And then as you start working with it for quite some time, obviously you become unconsciously competent. And it becomes very difficult to understand why someone else doesn't understand this, or you start to trivialize your own knowledge because you think it's just common knowledge, which of course it's not. So it takes time and it takes a bit of effort. But the main idea is just to start somewhere, even during the early phases of this week, just start your own little project. Another thing I just wanted to say, that these notebooks, one of the big problems here in Google Colab, of course, there's no spell checking. So you're going to see some spelling errors, and fix those for yourself. If you want to keep your own version of your notebooks nice and neat and clean, you can certainly go do that and fix all those little spelling errors. Of course, if you install Jupyter notebooks. So Jupyter is the way that, these Colab notebooks are built from Jupyter notebooks. The Jupyter notebooks are the original, and you spell that with a J-Y, J-U-P-Y-T-E-R, and it's just the J is for Julia and the R is for R, and the P in there is for Python. So it's just a name that they came up with just to show that you can use more than just Python here inside of Jupyter notebooks. But certainly, if you do a local install of a Jupyter notebook, you can also install a spell checker, and that of course will work for you. So perhaps someone can Google whether you can get a spell checker here in Google Colab, but I don't use one here. And so in these notes, you're going to find spelling mistakes, and more importantly, you're going to find coding mistakes. And I want you to find them. I want you to discover them, and feel good about the fact that you discovered them and fix them. That's what a course like this is about. I want you to get your hands dirty when it comes to this code. So what I want to do is just every now and again, I'm just going to check here on the side. Emil, you're keeping tabs of what's happening on the side, because that's a little bit off my screen. Emil, are you there?
Sorry, yeah.
So
Okay,
Emil and I will be answering the Q&A stuff and the chat room.
Oh, Kancho, you're still there? Great stuff.
Yeah,
okay, so I'm going to carry on. So I'm going to use this
you
very
do your
first.
stuff.
Yes, this very first notebook here. And I just want to, we've seen in the video how these work, but I just want to explore a little bit and just in case there's one or two questions still remaining about that. And as I said, one of the nice things about it, there's no need to install anything. And of course, if you in your Google Drive, it's very easy once these things do work, just to say new, more, and there's your Google Colab, and you start your own Google Colab. Of course, if you want to fix all the spelling mistakes and keep this notebook nice and neat, you can just go to File and then save a copy in Drive, and it's going to make a duplicate copy of this. And right up here it'll say copy 01, and you can just click in there and change the name. Leave the .ipynb intact because that's like a Word document is .docx. That tells the system that this is a IPython notebook. And the I in IPython, by the way, that stands for interactive. So we're using a very specific version of Python when we do data science. It's called IPython or interactive Python. And that's where we write little snippets of code and we can execute it and get the result immediately. On a larger scale, of course, you can use Python to write millions of lines of code and develop huge programs. And there's some very famous programs written in Python, and there's some very famous social media platforms that run on Python. You can do web development in Python. So Python is most definitely not only for data science. And so we're using a version of Python called IPython, interactive Python, so that we can write these, what we call scripts, these little interactive scripts, write a few lines of code and hit enter, shift return, and get the results. Then there's this normal file edit, all those things. I just want to run you through some of them. And one nice one is the move, because it's not as nice as your own computer, where you can move stuff around into different folders or directories. You can just use the move button. Specifically, if you've saved a copy, it's going to save it in a place where you don't expect it to be. So you'll have to go back to your directory, find where it was saved, and then you can always just right click on these and say move to, or when it's open, just say file move. And that's just to keep things organized. And that's certainly the way that I like to work. I really like to work with these things my files and folder structure fairly organized. The next thing I just want to make you aware of here under runtime, there's this idea of this change runtime type. If you click on that, the nice thing about the Google Colab is that it gives you a GPU free of charge. So of course we're not paying for using this Google Colab, but we also can get a GPU. Now, if you don't know what a GPU is, that stands for graphics processing unit, what people use to play games with. If you have a GPU in your computer, of course your games will run better, but they're also very good at, for instance, at multi-paralleled executions. In other words, if we create deep neural networks for machine learning, your code will execute a lot faster. So Google actually gives you the ability to choose GPU there. And now a GPU is enabled to run this. But certainly we'll get towards, say perhaps something more about that right in the end. For now, we're just going to use the hardware acceleration to none, because certainly running these notebooks, we're not going to do that. The point being is that you get quite a bit of compute power completely free of charge. Now you can do bigger projects if you sign up to Google Cloud itself or Microsoft Azure or Amazon's AWS, and you can get a lot more compute power, but that's going to cost you a bit of money. Of course, if your pockets are quite deep, you can put together a nice computer system for yourself and pay a lot of money and have a very powerful computer, but you can do all this online. But here on Google Colab, you get all of that for free. Of course, there's some limitations that your code can't run for too long, and then you'll have to kind of switch off and switch back on again. And the way that we do that is right up here with this connect button. And if I click on it, it says the manage sessions. And when you click on manage sessions, all the sessions that are open. So every notebook that you open and you hit connect, that opens a session. So it spins up an instance of Python and the Google Cloud on one of their computers. And as if you have a little computer sat there. And the way to shut them down is just to always go to that manage sessions, because if you have too many of your tabs open and running, Google is going to start complaining that you're abusing the system a little bit. But you can always go to manage sessions and then terminate all your sessions, and you can just spawn up some new ones, no problem there. Lovely thing if you do collaborate with people. Of course, this is just like Google Docs, that you can leave comments, as you can see up there. And of course, there is the share. There is the share button there with which you can share. So just a little bit of iteration again of these code cells here. Well, before we get there, let's just run down the left bottom here. I just want to increase my screen here a little bit. There we go. Of course, the table of contents, anything that you write that has these pound symbols in front of them so that they are titles and subtitles, you can put up to six pound symbols or hashtags there. They will obviously show up here in the table of contents, and that makes it very nice as a research document, because that's what these notebooks are meant to be. They're meant to be research documents or data science documents, because the fact that we can put normal English sentences here and we can put images here, you can link to YouTube videos right here, you can write links to do all of that. It makes it very nice as a research document or to collaborate with your colleagues. Collaboratory is what Colab stands for. It's just a short for collaboratory because it's for collaboration. That's what it's meant to do. And of course, you click on one of these and it goes to that section. This one, the next button from the bottom, is a very nice one in as much as it has little code snippets. So Google's very kindly written some code for us. And when you start coding for the first time, this might be one of your first ports of call. So there, how to do a histogram and Altair. If I click on that, there's a little bit of code there. And if I hit insert, it's going to insert all of that code so that I don't have to write that. And we won't use Altair in this course. I'm going to introduce you to Plotly, and which is an interactive plotting library. And one of the reasons why I choose that is this makes life very easy when you want to do interactive things. What I want to show you right at the beginning, though, if you go to my YouTube channel, so you can see there, it's very simple. It's YouTube and JH Klopper. There we go. I hope everyone can see that. You'll find this. Perhaps you can push me over the 10,000 subscriber mark there. That'd be nice. But anyway, there's a bunch of, there's over 1,400 lectures on this site. And many of them, especially recently, are on data science. And there's also a lot of mathematics on here. And with some strange things, I suppose, understanding the Euler-Lagrange equation. That is, certainly was one of my favorite videos. But what I want to draw your attention to is this latest upload that I did 2 days ago. It says matplotlib tutorial, because I saw in this morning's comment section, someone was asking this question about Plotly versus matplotlib. And we're going to get to a module where we're going to do plotting. And the grandparent of all plotting libraries is matplotlib. So those of you who want to look ahead a little bit, there's a whole tutorial of, I squeezed, as you can see, there's much matplotlib into 80 minutes as is possible. So this is a resource for you. You can always come to this channel, and there's a lot of information, data science lectures here. As you maybe want to check that out after the course, or in the evenings, if there might be some solutions to some problems that you're dealing with. So back here we go. That's one way that I, especially if I want to interact with Google, there's some nice just little code comments there. So let's go back up there. And then how we start our session, remember always, is the little connect button there. Of course, if you just execute any line of code, it will connect as well. And so I'm just going to hit the connect button that allocates some resources on Google's side, and it connects me to those resources, initializes the system on their side, and I'm connected. So I now have an active session of Python to get going. Now, before we get into coding and all of that, I think it's always worthwhile to spend some time and just learn a little bit about the capabilities of these notebooks. Of course, you would have seen that just to add new cells in between, you just hover in this little space between these cells, and you can either add a code cell or a text cell, depending on what you want to do. And then inside of these text cells, there's quite a bit of things we can do. So always, if you want to double click on them, especially if you start reading other people's notebooks, there's always a lot to learn about, some nice things other people do in their code. You can just double click on it and it opens up. And there's this nice toolbar, of course. If you want to make bullet points, you click the button. If you want to insert an image, if you want to insert a link, pretty much like you would think of a Word document or Google Doc, you can use bold and italics, etc. And then you can see this little greater than symbol right next to my name there. Of course, that gives us this nice little indent there with this little gray line. So there's lots of ways that you can go about. And in the video lectures, you'll hear me talk about the markup language, of course. And that is a way, just using little symbols, that we can format our code. And I think in the exercise sections, there are a bit that I just ask you to write something in bold and italics. And as you can see there, of course, it's very easy. Just put 2 underscores before and directly before and after a word or 2 words or a sentence, and that's bold. If you just put 1, of course, that's italics. And it really is, as far as I'm concerned, in all the research that we do, it's a very nice document to be able just to share with others. And then at the end of this first notebook, don't worry about any of the code. That's not what it was about. It's just to show off a little bit of the capabilities of what is possible. And you would have seen these, the Plotly interactive plots. You're going to learn how to do these. And if you hover over them, you see some information pop up. So these are nice interactive plots. And we can zoom into a certain section if we want. We can go back home. So we zoom back out. And of course, you can save these as PNGs. If you have to put them into a Word or Google Doc, a document for one of your projects, you just save these files as PNG files, and you can export them, save them, and export them. There we go. All interactive, as you see. If you hover over them, there's some nice interactivity there. There we go. So we just some of the things that we're going to learn what to do during the course of this. Someone this morning was asking about Decision Forest and installing them on their local system. Of course, here, as you can see, it's only available on Colab at the moment. I'm not quite sure how long it'll be before it's available on Windows and Mac to install. Certainly, you can install it on Linux already, as far as I know. Great stuff. So we're going to learn how to do all of these things. This is particularly interesting for me, that we'll do on Friday with the random forest machine learning architecture. So let me just go look at the chat. Anything specific we should mention, Emil, Conchu?
Doesn't seem like it at the moment. Just going through some questions and answering.
Great stuff. Okay. If there's a major thing, we can interrupt the session and we can certainly have a look at those.
Sure. So I'm busy replying to emails of people who can't seem to join.
Okay.
So I'm not looking at Zoom at the moment. That's
fair enough. Thank you, Ganshu. I just want to hope everyone has read this, because this was reading material just on the definitions. As I said, a very particular thing in data is just to classify the type of your data. Much of what we learn is to put things into little boxes. And when it comes to data, we also put those into little boxes. And we call those classification systems. So one of the ways to classify data types, or types of data, is of course into numerical data and categorical data. And I think that's very crucial to understand and ask questions if you don't fully understand this difference between numerical data and categorical data. The difference between ratio type and interval type, it is by definition there is a difference. Practically though, it's not that we run into this kind of problem every day, but it's nice to know. Something nice to know that there are these two ideas. And then there are two different ways, I suppose, also to classify numerical data, and that is as continuous data, where we just have decimal places, as many as is possible, or as many as our apparatus can measure. And this is this idea of a continuum, versus discrete numerical values. So if you can only do things in whole numbers, and certainly it's impossible to have a half of something or quarter of something. Those would be discrete numerical variables, and they're very important to know or understand that distinction. And then just 1 or 2 words about categorical data, of course, is the idea that even though we encode them with numbers, and later on we'll see when we do create linear models and we do modeling, or we do logistic regression, we can only use those kinds of modeling if your data is represented as numbers. And of course, when you take categorical data and you encode it as a number, just to please always remember that those are not really numbers. So if you come across zeros and ones, or zeros, ones, 2, 3, and 4, or whatever in your in the data, please always just make sure that you do understand that, or someone gives you that data. Just be clear with those, with the people who give you that data, whether that data represents a categorical variable or not. And because we handle this in a completely different way, when you analyze data and it's represented as numbers, but it is categorical data, we use different tests and we use a very different approach. And we cannot and should not analyze these as numbers. Just, you know, as a not 100% as a hard and fast rule, but I think a principle to stick to specifically in the beginning. I just want to say a few words just about the sample space as well. Very important to know, it gets much deeper than this in statistics, what a sample space might be. But for our purposes here, really, there's just this idea of all the specific values that a variable can take. And I think I have used the idea of age. No one can be minus 5 years old. It starts at 0, and certainly no one that we know of is 200 years old. But there's a very specific range, and every value can only come from that. And especially when we talk about categorical variables, that those variables can only come from a certain type. When we start working with data later in the week, and we talk about the concept of tidy data, very important. Perhaps I should just say a word or two about that now. If we think about a spreadsheet, every row on a spreadsheet, everyone knows Microsoft Excel or Google Sheets. Every row must be one subject of your data, and every column must be a single variable. And the values down that column can only be from a certain selection. So think about a hat with some names in it, and you can only draw from that hat to fill in the values down that column. So we are very particular when it comes to that. We will talk tomorrow, I think, or so. We will talk about horrible spreadsheet files and how people cram all sorts of variables into a single column. And of course, it's impossible for you or any software to analyze that kind of data. And we spoke about it this morning, about cleaning up our data. And yeah, I see there in that section, that is where I talk a little bit about the tidy data. And then one of the most difficult ideas, concepts in the beginning of doing data and data science. Data science is all about answering a question, getting some information, and it's about learning how to structure that question such that data from a data set, and whether that data set be tabular data or images or sound or something from a sensor, it doesn't matter what it is, such that that data can be collected and analyzed to answer the question. And you have to develop quite a bit of skill to state your research question. And so often in the beginning, you have nebulous ideas. I want to look at the outcome of this, and to start asking finer and finer questions until you drill down that research question into something that you can analyze from rows and columns of data or from images. It has to always come, the answer comes from the data, and that's why we talk about the data science. So not much there. The rest of not all of us get involved in randomization and randomized trials, etc. But I think some useful information for you there, specifically this idea of a parameter and a statistic. And I think you've all had an opportunity to read up on that. So enough about all of that. Let's get into the Python language. And this is just a very brief introduction to the Python language, and just starts off some of the skills that you might require during this first week, at least, or during your data science career. Everything that you will use builds from these foundations that we have over here. So what I'm going to do now, I'm just going to open this the exercise sheet, and I'm just very slowly going to run through that. You see that the solution set is there. I don't want you to copy and paste, so I want you, as I speak and as I type in the beginning, I'm going to do a bit of typing myself, and you'll have to excuse my typing abilities. And I want you, if at all possible, open the sheet. It's difficult always just with one screen, but try and get some typing done if you haven't already done so. And if you've done so, congratulations, well done. I'm proud of you for just getting some code started. So what you'll see here, there's a couple of other questions in this set here that is not in yours, just to keep things interesting. So there's a couple of, every now and again, I'm going to throw in a question that would not have appeared in your exercise set, just in case we can learn something new from it. So don't be intimidated by this new language. For those of you who speak multiple languages, hats off to you. I certainly wish I could speak more languages. I can help myself in a few, but this is also a type of language, and we have to learn how to speak this language. So the first one there is just to generate plain text cell below that, and we've already seen how to do that. And then, by the way, this little pop-up on the right-hand side also allows us to add a comment, to edit that, and also to move the cells around. That can become very useful, especially if you start adding things in between. Sometimes you just want to move the cell around, and of course, those are those two buttons for you. So for this one, we're going to generate a text cell below that, and it is for a second level. So that's just 2 there. Of course, many of you would have noticed you can just click on this little TT button there, and it's already going to insert 1 for you. Depending on how you set up your notebook, you might see results below it, or you might see results to the right of it. So if you do a text cell, you're going to see the effect of your text cell here on the right-hand side. So it's already populated a little bit of something for you. And if I click it twice or 3 times, it's going to add those hashtags or pound symbols so that we can have the right number. But I asked you to do 2 of them, and it's my first exercise. I won't type the rest. And of course, I think you've seen how to do that. So here, just want to show you if it's be different places on different keyboards. Sometimes it's on the left top of the keyboard. On a Mac, on a MacBook, it's on the bottom left below, just next to the right of the left shift key. There's this that little symbol. Perhaps someone can remind me what it's called actually. That little tick symbol there. If you put a little tick symbol before and after something, so as you can see there, it actually, Colab is nice enough and it prints it out to the screen that it looks like code. So if we run this code, it's going to increase the size of this just a little bit because I think this is terribly small at the moment. Yeah, it's better. If you can see, it's printed differently and there's a little bit of a gray background here. And so you can embed code. So if you want to explain to someone else what your code means, you can certainly put it right in here. So anything that you embed in those little tick marks, of course, it's going to appear like code. So just as a matter of interest, how that is done. And then there's one particular thing about using these notebooks. It's not always that we want to generate a table with code. And I'm certainly going to show you how to do that when we get to the pandas library. And that is how to generate, or, to display these tables of information. But you can just use simple markup language here to create your tables. And I saw someone wrote this morning in sheet number 3. There was, I think, let's just go down. Was there somewhere? Yeah, there was the mistake there. So in 03, the Python language for data science, 2 to the power 4 is, of course, 16. And I think there was an 8 in there before. So yeah, find those mistakes and fix them. But this is, one use for a little table like this. And from time to time, I have found it useful. So that's just a little experience tip for you to use code, like to use a text cell like this, just to create your tables. Every now and again, it becomes useful. But for most of the time, we're going to write a simple line of Python code, and when we import our data or generate some data, and it's going to print these tables for us. But I want you just to be aware of that. And I wanted you, of course, just to a word in italics, and I mentioned that a little bit before, a little while ago. It's just italics is just a 1, and 2 in front would be bold. And there's actually an alternative way to do this, and that's with a star. So star italics should also work. Italics and double star bold. I think that should also work. Of course, this one is going to connect first, this notebook, because we haven't run anything yet. And of course, that happens very often. Because for me, at least for me, using Colab or not using Colab that often, these 2 buttons are very close to each other. And if you want to be very quick, you click on the wrong one. So that happens quite a lot. So let's take this. And click on it. There we go, that's better. And the delete button, of course, is right there, just to delete that. So both of those are going to work, the underscores and the star symbol, Shift 8 on my keyboard, I think Shift 8 on most keyboards. So we asked there just to do some simple calculations, 3 plus 4 plus 4 minus 2. So let's do 3 plus 4 minus 2. And you can see there, I didn't put any spaces there, but of course you can put spaces in between and that makes things readable. What I want to very quickly warn you against is that white space. These are just, when you hit the space bar, that's white space. There's some more white space. In Python, white space, depending where it is in your code, actually means something. Python uses white space as actual code, which is very different from other languages such as Java or C++, object-oriented languages, where we make use of curly braces and semicolons, to do the work for us. Here in Python, sometimes white space, especially leading white space, can be used as code formatting. So if your code doesn't always work out properly, keep in mind that white space might be the problem. But certainly here, it's not going to be a problem for us. And we just put these spaces in between, it's just more readable. And of course, there won't be any problems with the arithmetic order or the order of arithmetic operations there. 3 plus 4 minus 2. It's certainly not a problem.
Can I quickly jump in here for a sec? Can you just show how to change a cell from text to code? Or from code to text. Stack Overflow says Control MY. Well, there should be some buttons somewhere.
Yeah, I just want to see if there's anything up here because okay, let's see who can come up with that answer. Who can come up with that answer? Because that brings us to another little point. Say again.
Stack Overflow says to change from code, to convert to a code cell, you say Control plus MY, and to convert back to a text cell, it's Control MM.
Okay, so maybe put that down in Discord or the Discord server there, or in the text, so people can copy and paste that somewhere to remind themselves of those. Which brings me just to another point, and it's an excellent point there. I just want to give you a brief glimpse. I hope you can still see my screen. This is called VS Code that you can see there, Visual Studio Code. Some of you might know Visual Studio. That's Microsoft's big coding environment program that you can buy, or there's a free version that you can do as well. And then they have the subsection of it called VS Code, which is absolutely free of charge. And the text is a bit small, but yeah, I run this very same notebook that we're looking at now, or the number 3 notebook at least. We're running here inside of VS Code. And this has all sorts of extra functionality, but this is also a notebook. I can open it here in VS Code. And perhaps later in the week, we can have a look at these other coding environments. And on all of these, the reason why I bring that up, in all of these, there are different shortcuts to change between cells of text and cells of code. But you've heard the Google it. Stack Overflow is one of the sites that indeed is going to show up many times when you look down the list of all the things that Google gets back to you. And certainly that is a place where I think most of us will find the answers to the problems that we're dealing with when we do some data science. Of course, you see there 4 plus 4 times 2, and of course the 4 times 2 is going to come first. That's just a bit of school mathematics. That gives us 8 plus 4 is 12, divided by 3 is going to be, of course, be 4. And the reason why I want to show you this, of course, is just this LaTeX code, or tech. And we spell that, if anyone has seen that, the way to spell it is latex, like this. That's LaTeX, or just tech. And that's a language, a markup language all on its own, and that is to typeset mathematical code, so that mathematical equations, etc., so that it looks very nice on the screen. And that's available to us right here in Colab or in other notebook environments. And we just put these 2 little dollar symbols in the front and back, and that's going to center the code for us. And if we want it in line with our sentence, if we want a piece of mathematical notation right inside of our code, we just put 1 dollar symbol. But if you put the 2 dollar symbols on either side, that's going to do that. And you can just see here LaTeX is something many of you will have to pick up in data science, specifically if you're working in a field like engineering or that's more math heavy. The ability to write LaTeX code to print your mathematical equations to the screen nicely is really a good skill to have. And it's very simple here. It's the keyword here is \frac for fraction. And you put the numerator, numerator in a side of curly braces, and you put the denominator in a side of curly braces, and you do that directly after each other, and no spaces in between there and there. And that, prints nice LaTeX to the screen, no problem there. And of course, here in Python, what we'll have to do is just to make use of parentheses just to force this order of arithmetic operation. And of course, the multiplication is the star symbol, and the divide by is the // key. So 4 + 4 × 2, and I'll have to enforce this numerator there. I don't have to put those braces there because multiplication becomes the parentheses, because multiplication comes before addition. But in any event, that is going to give us the 4. And you see there, it gives us 4.0. So that's actually a floating point value and not an integer. And in the notes and in the video lectures, you'll see the difference between those. So 100 divided by 3, very simply, is going to be the 100 /3. And that's going to give us this numerical approximation of the answer. So another thing, reason why I put this in, not necessarily because this is so simple to do. The reason why I wanted to put it in is just to understand that a computer works with rounding. It's got a round off. It can't put 0.333, wrap it all the way out your house through the door, out into the neighbor's garden. It has to truncate it some way. And that is a source of errors, because you're going to do some analyses and the answer is not going to come out right. It's because of this idea of truncating these decimal places. And there are different types depending on the bits that your computer can work with. In the old days, in the 80s, we had 8-bit computers, and then 16-bit, and then 32-bit, and now 64-bit. And you can actually force the system to save things as 16-bit integers or 16-bit floating numbers. And that means it can't hold very many decimal places, and you might have overflow error where the number that you're dealing with is larger than what that data type can hold. And then you're going to run into trouble. So this idea that we might bring up later in the course is to be very sure that the type of data, the data structure that holds this value, 100 divided by 3, is sufficient to actually hold that answer. And of course, what we see here is just an approximation. The actual value is 100 over 3. That is the definitive value. And then the numerical approximation for that is this answer that we see here. That's just truncated. But we'll certainly get into more of that. So I spoke about it in the lecture, and you've seen in the notes this great idea. Python is a core. There's a core to Python, the core part of the language. That's what the people who develop the language, they decide every now and again there's a new version. We're up to version 3.10 in development at the moment. And they bring out the core functionality. But the whole idea behind open source software is that anyone can look at how they did it, and anyone can add to that. And it's usually added either as packages or modules, and people use the terms interchangeably. And some people feel that modules are inside of packages. There's all sorts of debate over exactly what is what, but I think a true computer scientist will tell you the exact definition, and I think people might be hard and fast about it, but for our purposes, we're going to call them packages. And people just develop these packages, and we can just import them with the keyword import, and the package, in this instance, it is a module, is called math. And we just say import math. And math is a little bit of code. It's usually written in Python, but it can be written in other languages. Very commonly, it's written in C++. And then it's just what's put over that is what we call just a Python wrapper. So we write Python code, but behind the scenes, it actually does a bit of C++ coding, another computer language, object-oriented language, compiled language, which executes much faster than Python, but all we see on the surface is Python, so we need not be too concerned about that. So to import all the hard work that someone else has done to extend the capabilities of Python, it's very simple. We say import math, and that's it. And now we can use some new keywords, some new functions. And you've seen in the notes, you've heard in the lecture that, we use functions to do things. Functions are keywords in the language. They belong to the language, and they do some useful things. And so the developers of this math module has added all sorts of new functionality, and that makes it easy for us just to use the functionality in there. The way that we've imported it, though, we've got to tell Python that we want something from the math module. And one of the things that it does is pi, for instance, but we have to use, as we've imported it now, we have to use that word math.pi, the math, and then dot, and then whatever's inside there. And you can see, actually, Colab was very nice. It already brought that pi up for me. And it just depends on a couple of things. I typed the P there, and you see two things came up, pi and POW for power. It'll give you these little code hints. And if you use other softwares, such as VS Code, it's going to give you a lot more hints. As you type, a lot of hints come up, and you can just hit the tab key and select those hints, and it writes all the code for you. It really becomes much more powerful than we just have here in Colab. So we can just accept that little code hint by just clicking on it. That is indeed what I wanted, math.pi. And we see a first few decimal places of pi there. So in the next one, I was just asking about, I'm just checking up here, calculate the remainder. Of course, it was, I got distracted there by the data types. Of course, what we wanted here was the percent symbol, because the question really was calculate the remainder of the following division when you divide 100 by 3. If you divide 100 by 3, the remainder is 1, because 3 will go into that 33 times, which gives you to 99, and there's a remainder of 1. And the remainder symbol, that's the percent symbol, gives us the remainder. Perhaps someone can tell us what the integer, how to get to that integer value of 33. Maybe someone can pop that up in the chat. So this one was definitely how to get pi r squared, and pi r squared, of course, that I shouldn't say circumference there, huh? That's the area. So we double click on that, we fix that, and we write area. So please go along and fix all these errors and feel good when you pick them up. So if the equation for the area of a circle is pi r squared, how would we do that? And it's math.pi times, and the radius in this instance was 2, and I can just say another 2, like times 2 times 2, but in this instance, square is 2. There's 2 star symbols. In many other languages, you'll see it's the caret symbol, shift 6 on most keyboards, but in Python, it's 2 stars. So that's math times 2 squared. And that's going to give us the area of this of the circle, 12.566. And this math module does what it says on the box. It has a bunch of mathematical functions. And if I type math dot, I didn't put a P yet, and look at all these that came up for me. So you can, if you're not quite sure what it was, you can always just do that dot. As I say, it's not 100% functional here in Colab. And in some other coding environments, this becomes much more powerful, these code hints that pop up. So you can see when I type math dot, all the functions that are available to me are there, these little boxes. Those would be the functions, and I see the SQRT. If I click on SQRT, it auto completes that for me. And now I can just type in the number 53. I just have to see, what was it, 53824. Math square root, and we see the answer is 232. So here's I think one that you might not have seen. So this one is n factorial. So n with a question mark. If you're not familiar with mathematics, that will be n factorial, and where n is this natural number, just in the common case. And if it's, for instance, if it's 3 factorial, that will be 3 times 2 times 1. You just run it down in the steps of 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. And very easily there is, if you type math, and I think you can guess what this is going to be. It's going to be with an F. And if I start with an F, it shrinks those down to everything that starts with an F. And indeed, lo and behold, there's factorial and 7. And of course, The 7 factorial is quite a big number already. If you think you're just multiplying 7 by 6 by 5 by 4, 3, 2, 1, it already gets to 5040. And that's, of course, a sequence that expands quite rapidly. So in this next one, I wanted you just to create just a string. And of course, strings, I want to tell you a little bit about strings. Conchu spoke this morning about NLP, natural language processing. Of course, there we work with the written word, and we can import a corpus of data, and we can vectorize that so that we have numbers to deal with, etc. So sometimes in Python, and depending on the type of data science that you're going to do, it's very important to be able to work with strings. And all I wanted here, I think, is just to say I loved data science. And you can see here this idea of a computer variable. That is under your control. You can name that whatever you want. Of course, there are some constraints. And I think one of the questions that I ask is, why can't I use, for instance, the computer variable named dict? And I hope you know why you can't do that. So that's under our control with a bit of constraints. This is called snake case, the type of name, and that's putting these underscores between words. If you put underscores to string a couple of words together, that's called snake case. And there's also other conventions, but in Python, definitely snake case is one of the most common to use. And the whole idea is to make these names memorable so that when you look at this code again, or you hand it to one of your collaborators, they can sort of guess at what that calculation is doing based on the name that you gave it. And as I mentioned in the lectures, that just generates a little space. You can think about it as creating a bit of space in your computer memory. And that is where you assign some information to that little space in computer memory. And we do this assignment by the equal symbol. So that has nothing to do with the equal symbol in mathematics and computer languages. In most computer languages, this is an assignment operator. It assigns what is to its right. It assigns that to what is to its left. And to its right is the string I love data science, and to its left is this name that you decided on. And what we assign is of a certain type. And what is here were these single quotation marks, and I'll mention double quotation marks and its use, is the fact that it is a string. That is how Python knows that what you've given it here is a string. So we have a string object here, which is an instance of what we would call as an abstract string class. But anyway, it's this object, and we're assigning it to this computer variable so that we can reuse it later. So the single quotation and double quotation, most definitely, we can use double quotations. There is no difference in Python. And the reason why both exist is I might want to put love inside of quotation marks. As long as there's an inner set and an outer set, and they don't interfere with each other, and they form little pairs, you can certainly do that. But it might be that you want to put double quotation marks somewhere inside. You can certainly do that. So on an easy level, they're interchangeable. So you can make use of either. I think initially it was much more common for us all to use single quotation marks in Python and other languages such as R or Julia. It's much more common to use double quotation marks. Now, one peculiarity about Jupyter Notebooks is it doesn't print to the screen, and that's perhaps more specific to Python. It doesn't automatically print this result to the screen. You actually have to call this object using the variable, so that it calls that object that you assign to it in that piece of memory, and then it will print it to the screen. In other languages such as Julia, when you assign an object to a computer variable, it'll immediately print it out to the screen. But here in Python, you have to call that computer variable, and then it'll print to the screen. So in the next section here, I wanted you to do some concatenation. So let's just read this. Create a computer variable called my statement. So we're going to have one my statement. There we go. And at my statement, add the sentence, and I will use it for good. So let's do that. And I will use it for good. And there we go. Concatenate my passion and my statement. So how can we put strings together? And that is a very useful thing to do if you're dealing with string data. So I'm just going to show you that. It's not something that many of us work that often, but certainly if you are in a field that uses that, it's quite important for you to learn more about the management of strings in Python, and it is very powerful. There is a lot you can do with string manipulation. So concatenate means bring those two sentences together, and for that, one way to do it in Python is to use the plus symbol. I'm just going to use the plus. The problem is if I now put my passion plus my statement, you'll very quickly see what the problem is. If I spell out my statement, there we go. I love data science and, so there's no space between the science and the and, because if we look right at the end of science there's certainly no space there. And if I look at the beginning there, so you can either put a space there, which is not what the question asked for, but of course that is going to insert the little space there for us now, is that we can just insert that with code. So I can say plus, and then the quotation mark, space, quotation mark, because that's a space as well. That's quite a legitimate space. And there we go. I love data science, and I will use it for good with a space put in properly there. So there are many of these little things. I'll just mention one or two of them. If I put \n, that is a new line. So it's actually going to introduce a line break for us. Well, maybe someone should just check on that. Why is that not working? And I can tell you now why that is not working. And I'm going to give you a clue, and perhaps someone can find it. It has something to do with a print statement itself. Anyway, so for now, what we want is just that space. There we go. I love data science, and I will use it for good. If you need to repeat stuff, so let's do my passion. And just to repeat stuff many times over, and of course, there's not going to be any spaces now, you just do multiplication. And now you'll see I love data science three times over. So the next one is a bit tricky. So there's only a few more of these, but I think I wanted to introduce you to strings, which I don't think is really mentioned in the lectures that much. But I want you to show you that this exists, and if you're interested in it, that's your homework for tonight. You're going to learn more about strings. So create a computer variable called me. So let's say me equals that would be me, and let's say that what is the other one? Friend. So let's put Emil's name in there. And so certainly those are the two, what it asked for. Now it wants me to print this hello friend, comma, my name is, and put those actual values in there. We've saved them as computer variables now. What if we wanted to use them? So the print is one of the functions, keyword functions, keywords in Python. And this is another nice thing, which I think the majority of you would already have seen. Once you inside these set of parentheses, which always follow a function or a method, and you're going to learn what the difference between functions and methods are, to some approximation at least, is that this tooltip pops up and it tells you what you can put in there. And of course, these things that we put inside the parentheses, those are called arguments. In other languages, they might be referred to as parameters. But it's the information we give to the function so that it can actually do its job. So what I'm going to do now is I'm going to type this for you, and I'm hoping that it's going to run. So let's have hello, and I'm going to put a set of curly braces there, comma, my name is, and I put another set of curly braces and a full stop. And then I'm going to do something funny. I'm going to say, oh, let's just put that and close that up. So all of this is a string now, but you can see I've got two placeholders there. The two sets of curly braces are placeholders. So you can well imagine that I can put something in place of those placeholders. And the first thing is I want to put Emil's name there. So I'm going to use the computer variable friend, and then I'm going to use me for the second one because I've saved these now as computer variables. So I'm just going to say dot format. And inside of format, which is a method, I'm going to put friend to refer to whatever is held in friend, and then me. And let's run that and see. And then it says, hello, Emil, my name is Jean. So exactly what we wanted. Let's put that full stop just to close that sentence off. So there's this whole idea of programmatically that you can interact with strings. That was really the the idea behind this, just to show you, to sort of showcase you that it is possible to work with the spoken word, or the written word, at least when it comes to this. I think, yeah, there's one more here. And this is just, again, don't be overawed by this. This is just for those of you who are interested in strings and string manipulation, that you know that this exists and you can run with it. So what I'm asking here is use the % symbol to show how many times 3 divides 100 as part of the string. The number 3 divides 100 times, and show it to 2 decimal places. And there's one spelling mistake there. Of course, I promised you that there would be a lot, and you can fix those for yourself. So what I'm asking here is to constrain this result just to 2 decimal places. So if this is not particularly what you're interested in, just work on a little bit of other code or read some of the code comment. I just want to show you here that this exists. I certainly don't want you to be overwhelmed by any of this. What I'm saying is the number 3 divides 100. And then I'm going to do a funny thing. I'm going to say %.2f times. And we can make use here of the set of curly braces to be placeholders for us, but we can also use the % symbol to be a placeholder. Those are the 2 ways to create these placeholders inside of strings. And the .2f says I want a decimal value, a floating point value, but I only want to see it till 2 decimal places. So I just want to show you the existence of this sort of finer detail, and then we put our % symbol out, and we just say 100 divided by 3. So what the code is going to do here, it's going to look at this calculation, do 100 divided by 3, and it's going to put that in this spot here. So you can see that this % symbol, unlike these curly braces, they don't need the dot format. You can just put the % symbol there. And if I didn't do anything wrong, you can say that the number 3 divides 133.33 times, and it only printed 2 decimal places to the screen. A little bit more just about the text. One thing, many times in a data sheet, someone will capture numbers, but they'll capture them as strings. You can do that in Excel, in Microsoft Excel or Google Sheets. So it would say the number 234 there, but it was actually saved as a string and not as a number. And that can cause a bunch of problems. So I think this one is worthwhile to do, because I might want to add these 2 numbers. I might want to add 1 and 2. So these are my computer variables. I've assigned these 2 values to it, but they're not numbers. They are strings because they're inside of quotation marks. So I can certainly not say 1 plus 2. What is that going to do? Can you remember what that's going to do? String concatenation. And that's certainly not the addition of those 2 numbers. This is really not what we're after. But we can change the data type, the type of this object that's inside. And to change numbers, it's not always possible, but in this instance, it is going to be possible, and that's to use the float function. So I'm saying float, and the argument that I'm passing to it is 1. So it's going to take this 234. It's going to plonk it in there, the string, but this float function is going to convert this string into a number. So as I say, it's not always possible. But in this instance, it really is possible. And there you can see the addition of those 2 numbers. Very easily there, if I want to convert the other way around, there's the str function. So if I put str 300, that stands for string. So now I'm passing a number to that function. And you see when it prints out, there should be, there is 2 little quotation marks there. And you see it's Google Colab also uses the single quotation mark standard instead of the double quotation mark. So it's that 300 is now no longer a number, it's a word. And that is how you convert between, or one easy way to convert between strings and numbers, and that can become quite useful. I see I put a lot of stuff about strings in here, but sometimes it's fun. So this, I've put this string in for us here, string equals data science. So that's a string because it's got quotation marks. I'm assigning that to this computer variable called string. No problems there. And I just want to print everything uppercase. So in this instance, I'm going to use the print function, and I'm passing string to that, but I'm using this method called .upper, open close parentheses. So we are going to talk a little bit about this idea of a method. A method is really just like a function, but it follows something that's already been created. So I've created this object called string. And then if I put a dot and then the function, because you can clearly see this is a function, upper and open and close parentheses. So that's very much a function, but usually in this course though, as I said, to first approximation, we're going to call this a method. So it's string dot upper. And if I print that out, it's all going to be uppercase. And if I copy and paste that just to save some time for obvious reasons, and that's what I said why Python is lovely. Once you've seen one thing, you pretty much work out what it should look like if you wanted to do something else. And if I say string dot lower, and there no argument goes inside of this, see these are the empty set of parentheses. So not all functions have to take an argument or parameters. But you see there to the screen, it just printed both of these things. And here's a lovely little one that I threw in. I thought I liked. Here I've got a string, and this is also very common. Sometimes you import data, and it's just all imported as strings. And so we see the computer variable is called information, and that's assigned to the string. It says neutron star, comma binary, comma yes, comma 1.5. So that's some astronomical data there. And what we might want to do is we just want to break this apart. So in that lecture, in this notebook 3, I talk about all types of collections, whether they be lists, tuples, dictionaries. So that's certainly what this is about. But I can now call information. Remember, information holds the string here. And another method that we can talk about is the split. And that's going to split up this one string for me, and that can be a sentence, and I can tell it what I want it split on. And what I want it split on is the comma space. So there's a comma and a space, and there's a comma and a space. And if I were to do that, what I'm now going to get back is a Python list. And I know it's a list because there's a set of square brackets around it. And the first item now, first element in my list is neutron star. Remember, Python is 0 index, so that's actually my 0th element. My second element is also a string. My third element is a string. And my fourth element is also a string. So that's index 0, 1, 2, and 3. They're all strings, but they now exist as a Python list. And it might be easier when I analyze my data that it exists in a list. So in this question here, you can quickly read it. Assign the list above to the computer variable x232. That might be a way that you've encoded your data. It might mean something to you. And convert the value, that should say 1.5. Convert the value 1.5 into a number. So that might be a slightly more advanced topic for right now, but let's attempt it. So x232, I'm going to say that's information. And see, information already popped up. So this notebook keeps track of all the variables that we create. So when I just typed in inform, it already says information. I can hit the tab key or click information and it'll auto-complete that for me. And we wanted that split, and we wanted that split on the comma space. And now, so all I've done is this value here I've assigned to a computer variable here. So this is now assigned to a computer variable. We remember, if you watch the lecture, if you read, that we have an index to each of these elements, as I said, 0, 1, 2, and 3. So what we want to do now, that should be an x, x232, and then in square brackets, the third element, element number 3, which remember is now this 1.5, 0, 1, 2, 3. I'm going to overwrite that. I'm going to assign to it something new, something brand new. And what I want is the float of x232 3. So yeah, as I said, the first time you see code, this might be a bit, look a bit weird, but if you break it apart, it's quite easy. This x232 square bracket notation 3, that means the third element in x232. x232 is now this thing, which is this thing. And this 1.5 is definitely what I am passing. That 1.5 as a string is exactly what I'm passing as an argument to the float function, which we've seen now, and I'm assigning that to that third element. So I'm overwriting the value that's in there now. So if we print x232 to the screen, we now see neutron star, which is a categorical variable type, so no problem, it's a string. binary, it's a string, yes is a string, and 1.5 is now actually a number. There's no quotation marks around that at all, and it's now a number, which means if I have a bunch of this on different stars, I can do calculations on that last column, which will all be numbers. So you can well imagine that this might be useful to do. So just a little bit about the dictionaries. I just want to say one or two extra words on that. And remember, that's how we created this table. And I wanted you just to generate that as a Python code and call it myDict. And then, by the way, we might as well see this question here. Why can't we use a computer variable named dict for our dictionary? Because dict is a keyword in the language, and that is a big no-no. Don't use one of the language's own words, its own functions, its own keywords as your own. Don't try to tempt fate by overriding them or doing something. In most instances, that won't work, but it's just something just to bear in mind. Don't, you've got to come up with your own things. And there's obviously the two ways to go about this. Curly braces in the code itself indicates to Python that this is a dictionary, and it's always key value pairs. And those key value pairs are separated by a semicolon. So I wanted mean, and I wanted, what was it, 12.8, and then a comma and a space. Just put the space there for readability. The next key value pair was going to be standard deviation, and colon 3.4, and then IQR, which we'll learn all about. If you don't know what IQR is, that's coming up when we look at summary statistics. That's interquartile range, and we want the interquartile range to be 5. And I can say myDict, and that's going to print out all these key value pairs. And in the lecture and in the notes, you'll see how to extract only the keys and only the values separately from each other. I just wanted to show you, I think let's just make another code there. I can also say myDict and use the dict function itself. And you can assign that. The only difference there is that you are going to not use the colon. You're going to actually use the assignment operator, but there's definitely the dict function. And what we see here, some people refer to this as syntactic sugar. Syntax, of course, refers to the actual way the language is structured and the keywords and the function names, etc. And sugar, meaning you make it look a bit easier. So syntactic sugar. So we might type these curly braces here to indicate to Python that this is a dictionary, but behind the scenes, Python is actually seeing this word, this function dict, and that you're assigning these values to the different keys. So that's just a bit of syntactic sugar for us there. Great stuff. Print all the values to the screen. Just the values, and yeah, that's what I asked for. So it's myDict, and then the dot values. The values is what we want to see, and then it's obviously just going to print the 3 values for us. And we can also ask for the keys, which is then just going to print mean, standard deviation, and IQR to the screen for us. So I'm hoping everyone is okay and that the questions are answered. And we can certainly spend some more time on this after the fact, but let's get through this, this set of questions. Loops are quite important. I think you will see that you are going to make use of loops quite a bit in your code. When we get using NumPy, we'll talk about a whole different paradigm, and that's the vectorization of your code, but don't be concerned about that for now. I mean, loops are very, very useful. So we ask there just to print those values to the screen. Square each of the integers up to 5. One way to go about it will be loop. So I'm saying I equals 0. That starts my counter, remember. So it's nothing magical. To the right is a number, and I'm assigning it to a computer variable. No problem there. While I is less than 6. And in the lecture notes and in the video lectures, I talk about these things called conditionals. Also an extremely important thing in data science. And it's one of the most key aspects of data science, because when you import data, when you work with rows and columns of numbers or categorical variables, you want to use conditionals to select only some parts of your data. So this becomes a very important thing in Python, in data science using Python, this ability to understand what this less than or equal than or greater than or equal to, what these things mean. So we'll definitely get lots of opportunity to talk about it and for you to exercise, using the exercises yourself. This idea of conditionals are very, very important. And a conditional, really, just to reiterate, that is something that you ask of the computer and it can either return true or false. That's all it can do. It can only return true or false. That's a conditional, and it's something that is used all the time in data science. You're going to use it all the time. Now we end this while sentence here with a like syntax here with a colon, and of course if you hit enter, automatically Colab's going to enter a bit of white space for you. And that's where I said that white space is actual code. If you started writing the next line of code there, right on the left margin, you're going to run into problems. So that white space is put in for you there because it means something. It separates the code so that Python understands that this is part of some whole, this while loop is part of some whole. So I just want to print I squared to the screen. So it's I squared there. And then I just have to increase my loop counter, I equals I plus 1. And then this is where I mentioned before that equal sign is not a mathematical symbol because that means nothing in mathematics. That would mean 0 equals 1. And that's a whole different story. It says what's on the right at the moment. First time this runs through, of course, I is 0. So it's saying 0 plus 1 there. And that is now 1. And that gets reassigned to what it's to its left. So it's overwriting what's already in there. So it changes from a 0 to 1. We loop to the front. It checks this conditional. I is now 1. Is 1 less than 6? Can either return true or false. It returns true, which means it will go through the loop again. When we get eventually to I equals 6, 6 is less than 6. Well, that's false. 6 is not less than 6. And we exit that loop. And again, I think in the code, I showed you some syntactic sugar, some lazy code there. I plus equals 1. That's the shorthand for I equals I plus 1. But in the beginning, I'd rather have it printed out there so that it makes sense. So the next one I ask here is not in your exercise set, but I thought it'd be fun just to throw it in here. And there's a slightly derogatory term to this. If you go for a job interview, someone might, and they want to test your skills, they might ask you to do exactly this thing, which carries a name from a movie, as far as I understand. But the question is a real question. So for the integers on the interval 1 to 20, so 1, 2, 3, 4, 5, 6, 7, 8, 9 to 20, print only those that are divisible by 3 using a for loop and an if statement. So I don't want to see 1 there. I don't want to see 2 there. I don't want to see 5, 7, 8, because those are not divisible by 3. So divisible means there's no remainder. So can I write a simple for loop? Yes, I can, using a for loop with an if statement. And statement, let's write statement. There we go. So let's go about this. So I've got to do a for loop, and I'm going to go from 1 to 20. So remember how the for is used for I, which is just this placeholder. For I in range, start at 1 and end at 20. So I've got to go to 21. So this is a very important thing in Python. Python is 0 index. If it will start counting at 0 unless you tell it to. This range function, by default, it is just going to go up in steps of 1. So it's going to start at 1 and end in 21. 1, 2, 3, 4, 5. But in Python, in most instances, there's some instances that it's not true, but in most instances that 21 is not included. It's outside the interval. So 21 is not included. This is only going to go from 1 to 20. It's always less than this value at the end. This is something always to keep in mind because it catches you out every now and again, specifically if you use other languages as well, and other languages that 21 would be included. So when you hop around between languages, there's always that little mistake. So I %3, so that for statement is going to run through this 1, 2, 3, 4 until it gets to 20, and then it's going to get out of this for loop. But inside the for loop, I want this % thing. Remember, that's going to return the remainder. So at the moment, I is 1, so it says 1% 3. And what is the remainder there? Well, it's not it's not 0, so we don't want to print it to the screen, but we are going to use a conditional, equals equals 0. Now this is more of the equation, the equal sign that you see in mathematics, the double equal symbol. So it's saying, is this equal to 0? So if I take 1% 3, the remainder is most definitely not going to be 0. So it's going to return a false, and whatever I do now is going to be ignored, and what I want is print I. So I'm just going to execute this code. So let's quickly see what happens. Oops. Just to see for I in range. What am I doing? Forgetting the in keyword there. For I in range 1 to 21. So first of all, it's going to be 1. So it runs through. If 1 divided by 3, 1 divided into 3 has no remainder, then it will print that I. But if it returns a false, which for 1, it will return a false, this print I is not going to work. Then it's going to go through the for loop to 2. And 2, it's not going to work either. The remainder is not 0, so it's not going to print out. Now it gets to 3, and of course 3 divides 3 with no remainder. So this returns a true as soon as this hits 3, and then it's going to print out. Otherwise, every time it's false, it's going to ignore this part of the if statement and just run through this whole thing all over again. And in the end, what you can see, there's 3, 6, 9, 12, 15, and 18. And as I say, this is a famous question in some interview sessions, and it's just to write that, come up with that little line of code. And this is purely just a bit of show off. You know, you can also do this without for loops, just with list comprehension. And I think I do mention in the lecture sessions what this is for I in range. What list comprehension is, at least 1 to 21. If it will be I%3 equals 0. So this would to be exactly the same thing. Now the reason is why I bring this up is just to bring this point home. There are almost always more than one way to do things in code. And some things are more efficient, and some you pick up over time, and that just builds your efficiency, and you can write code faster, and you can you know, be slightly more productive. So these two things, this list comprehension, which is what this is, and this for if loop there, they should do exactly the same, unless I made a little mistake. No, they are. The only thing is it returned a Python list object for me there with those elements, with those 6 elements. But those do exactly the same thing. And as I say, this is something that comes with time. The most powerful idea to take away from this, and the reason why I wanted to put it in or added it, I think after the fact, was just to bring home the point that there is more than one way to solve a problem with a computer language. So you can, and in the beginning that's confusing, because you just tell me the way to do it, and I just want to memorize that way to do it and just always use it like that. But there's this flexibility that starts developing in your mind, and it has very much to do with how you tackle a problem. How you structure this idea that you have in your head, this data that you have in front of you, how do you convert that into lines of code to do that bit of data science? And that is certainly a skill that comes with time. And what I want to show you here, I'm repeating myself over and over again, but it is very important that I want for you to know that there's more than one way to do it. And that's why I think why I want you to do this, to do the exercise, is find another way, Google another way. If you get stuck, you are going to see a different way to do some of these things that I'm coding here. And that's powerful for you to explore and to experience. I think, yeah, I just want to do the exact same thing, but with a while loop. So I might say I equals 1, that's going to be my counter. And I'm going to say while I is less than 21. So that'll keep on working until I gets to 21, and then it'll exit because it'll return a false. And then again, I%3 equals 0. And then I wanted to print I. And the reason why I bring this in is because of the next little thing. So I want you to pay attention to this one. So this while loop is going to do exactly what the for loop is going to do, and it's going to do exactly, in essence, what the list comprehension did. But if I hit return now, you can see my cursor is in line with the P for print. And I said to you in Python, white space is important because that's the wrong position for us to be in. Because my counter has to be outside of my if statement. So I've got to hit the backspace key and get one to the left, one sort of tab worth of white space to the left, and then say I equals I plus 1. So instead of just showing you that there's more than one way to do it, this will be exactly like the for loop, just using a while loop, is this idea of the white space. So see very neatly what is in line with what. This print is part of the if statement. And it'll be put in the right spot for you because of that colon symbol there, the colon symbol. But you might want to do more than one thing in an if statement. So when I hit return or enter, Google Colab thought I wanted to put more stuff in my if statement, but I'm done with my if statement. I'm outside of my if statement. My if statement only checked whether that equals 0, true or false, and it will do what it has to do, and then it gets out of that if statement. My while statement is what increments the I by 1 every time. So that has to be in line with that I for if. So just to make you aware of it, this exists. Be very careful with your white space.
Can I jump in here quickly?
Yeah.
Two things. Can you just try and purposefully make an indent error quickly, just to show everyone what happens if your white space is wrong?
I want everyone to try that on their own.
Because we have had a couple of questions of indent errors. So I mean actually have an error in the code.
So look what is happening now.
Oh, now it's running forever.
Now we are stuck. We are now in an infinite loop. And this is a problem. So it's a good thing that we run into this problem, because we're not going to get out of there. We can't execute another line of code. We are absolutely stuck. So let's try and get out of it. So there's a little stop sign in front there, and you can hit that and it'll stop the execution of that cell. Otherwise, you'll get out. You won't get out of there. And this is what Amelia spoke to about first. You get these little things pop up, and depending on what notebook environment you use, they might pop up in a very ugly pink. I think you mentioned that pink before. And certainly when you import certain things, you're going to see those ugly pink boxes, but here it's just normally white. And it tries to give you an idea of what the problem is. And many times there's a code error. And in the end, you're going to start to learn how to write your own functions, create your own user-defined functions, we call them. And it's very important to put error code inside there. And I think I'll show you how to do that. Or otherwise, we can keep that as something that I need to make an extra video about. Give your user a reason why your code didn't execute. So in this instance, it shows us, tries to show us where the problem is, which it doesn't really get right. In as much as, we might be trying to do something very legitimate here. But of course, it doesn't work out for us because the loop counter, the increment of that loop counter must be part of the while statement there. And as we've mentioned before a couple of times now, Stack Overflow, when you just do a normal Google search and you see some of the websites that pop up most of the time will be Stack Overflow. And certainly that is where Google actually sends you when you have this this problem. So you can certainly just go there and try and search for a solution to your problem. And in the beginning, and let me actually be very, very clear about this. If you follow data scientists on social media, I mean, one thing that will pop up every now and again, it does not matter how senior that data scientist is, we Google the solution to a problem all the time. That is normal. No matter how experienced you get, there's always a little bit of that, of the code that'll catch you out and you have to look it up. That is just absolutely normal. And you can think about that with a normal language as well. You might be absolutely fluent. You grew up with a language. I bet you there's many, many, many words in the English language, if we can refer to English, that you don't know and have never even heard. That's just normal. And the same here goes for computer code. So make an error and search on Google for a solution to that. And one of the other great reasons why Python is so successful, because it is open source, anyone can contribute. It's a massive worldwide community and everyone puts the answers out there and you can just find them, which does not exist for many, many instances of proprietary, expensive computer tools, data analysis tools such as SPSS, etc. You won't find that community. You do, make no mistake, but the Python community is just so enormous that you will find your answers. Then we're almost done because I'm just going to import a package for you. We've seen that import of math, and in the lectures, you'll see me import it with a namespace abbreviation. So I use this term namespace The namespace is what we refer to as all the keywords that are in the language. And we add to that namespace. We add new names in some way you can think about it this way, is that you're adding new keywords, you're adding new functions to the language. So you're adding to that namespace. So we're going to use a namespace abbreviation, which is used most of the time because we're all a bit lazy. So it's import NumPy as NP. Now, I'm going to tell you about a very famous person in the data scientist world, Lorena Barber. She's a aeronautical and aerospace engineer, academic, and has been the president of the IEEE and all sorts of very impressive things. And she used to have a postdoc student, and he started this whole revolution of trying not to use namespace abbreviations such as NumPy, because he says, is that really the worst thing in your life to add MP, add 3 extra characters when you used it? So he started this whole crusade. I'm just telling you a little bit of side note, because these are names and people that you can look up and learn a lot from. So he just used to say NumPy, and then everything he wanted to do was NumPy dot array or whatever. And he was very much against this as NP. But this is the norm. His crusade didn't last long, which was quite funny at the time. But import NumPy as NP. That's a namespace abbreviation, and the namespace referring to, you can think of it, everything that's inside of NumPy, all the keywords, all the functions inside of NumPy is now brought into the namespace, the active space, the space of all these keywords and functions is now available to us. By the way, NumPy is not written in Python. Most of NumPy is written in C. And as I mentioned before, that's a language that is not an interpreted language like Python. It is a compiled language, which means your CPU and your computer can execute that compiled code a lot faster than it can interpret this code. And another part of the reason for the success of Python is using other languages in a way that it now expresses keywords and functions in Python that we can use in Python, but behind the scenes, it runs this much more efficient code in other languages, solving some of the speed issues. Now, NumPy, SciPy, Pandas, and then Plotly or Matplotlib, whichever one you end up using one day. These are the important ones, and you're going to use them all the time. And NP stands for, or NumPy stands for numerical Python. It is excellent for numerical computing. You can do a lot of this just in normal without NumPy, but the execution is just so much faster. It's such a richer environment that NumPy is also one of those grandparents of all packages, and many packages actually use NumPy behind the scenes as well. So I asked you just to generate that line of code, and it might look very foreign for now, but just a couple of days from now, that will look very normal to you, and you're going to use it all the time. So again, I've imported this namespace. So all the functionality inside of NumPy, I've got to refer to the namespace, which is now not NumPy, but NP, because we used the abbreviation. There's a module inside of NumPy called random, and it's all about random number generation. And we're going to talk about random number generation quite a lot, because that's an important thing in data science. So inside that module, inside of NumPy, there's a function called randint, and that stands for random integer. And this just says, give me a bunch of random values. And what the randint does, it takes these three, takes more, but in essence, it takes these 3 arguments. And you can see my arguments separated by commas. The first one is 10. The second one is 20, but I'm actually using the name of that 20. And those arguments are called keyword arguments that you actually give their name. So this 10 didn't have something like start equals whatever. We would just refer to that as an argument and something that you, now in this instance, you don't really have to, but when we add a name and we do an assignment when it comes to an argument, we call those keyword arguments. It's a bit more in depth than that, but that will suffice. And the size is 300. So I'm saying take this interval from 10 to 20. And in that interval, so it's an integer, so it's only 10, 11, 12, 13. Give me back 300 values. So you can just imagine it's like all those numbers written on a piece of paper. You put your hand in, you draw one number out. Maybe it's 11. You write down 11. You take that 11, you throw it back in the hat. If you didn't throw it back in the hat, there's no way you can get 300 numbers on the integer interval from 10 to 20. So you throw it back in the hat, and this is going to become very important to us. When we get to bootstrapping, bootstrap resamples, when we get to confidence intervals, this is exactly what we're going to use, this idea of resampling with replacement. So we replace that 11 back in the hat so that it can be drawn again. And so let's actually just print that numbers to the screen so you can see what it looks like. So it's going to give me this NumPy array. And one thing to note there, of course, there's my 300 values, but the 20 is excluded, as you can see. So once again, one of those things that you must just be aware of. And if this was important for you to have generated these numbers, and it was important for 20 also to be included there, that might lead to some error in your analysis. So just be aware of that. So there is those values. Oh, I see the next question was indeed just to print those out to the screen. So now that's assigned in computer memory, that array will print out, and Python will tell us that this is actually an array. It's not a list. Certainly there is a list, and it's inside of this array. You see the square brackets there in the beginning and end of those 300 values. So there's a list inside of that, but the object is no longer a Python list object. It is now a NumPy. It is now a NumPy array. And I think I go through at length to talk to you about indexing, and really read those notes or watch the video again, because indexing is also a very important aspect of data science, because together with conditionals, that is what we're going to use to extract only certain parts of our data in our analysis. Now, we don't want to analyze all the data. There's some meaning to the data, and we only want to extract certain values. And one way is to use indexing, and the other way is to use conditionals, and that's going to become very important to us. So for numbers, and I want the first 5, I talk about it in the lectures, there is this idea of just using this shortcut of just putting :5, which just says give me everything up to 5, and we'll see those five values there. And I think in the notes, on the lectures, I also make use of this little shortcut. If you don't know how many there are, you don't know what the last one is, there's always this -1, which is just this little shortcut code to give us the last one. Now, when you run this code, you're going to get something completely different from me, because, well, you can work out what the probability was of not getting that 17, seeing that we have a specific interval from which we choose. Is this random number generator there uses an algorithm, and it produces what we call a pseudo-random number, because it isn't truly random. Very difficult for us to get to real random values. I mean, the decay of an atomic subatomic particle might be, or say the decay of a proton or a radioactive nucleus. Let's not say the decay of a proton, because I don't think we've ever, the universe is not old enough that we know that protons will decay. But anyway, if we talk about the decay of a radioactive element, under the weak interaction, there is obviously going to be some decay, but that happens at random, and that's truly random as far as we know. But in the computer language, there's a little algorithm that runs behind the scenes to generate a pseudo-random value. So for all intents and purposes, the values are random that are selected, but each time you run this code, so if I ran it again, the last number is now 13, where it was 17 before. And there is a way that I'm going to show you to generate the same numbers over and over again. That's for reproducibility and for teaching, and we'll certainly get into that. Don't worry about all this NumPy stuff now. We're going to definitely get into that. I'm just throwing a bunch of information at you so that you become consciously incompetent, that you know that it exists. So this one is one I wanted you to Google to get the answer. And I wonder if you didn't look at the solutions, it's easy enough to look at the solution set, but could you do the geometric mean of the first 5 of those numbers that I put there, 3, 4, 5, 6, and 7? And I'm not keeping, because it's too difficult to keep my eye on all the questions there in the session, but I wonder how many got it. If you didn't look at the solution set, let me just do it for you. So SciPy is short for Scientific Python, and it's built on top of NumPy, so it actually extends NumPy. It has got a module that we're going to work with quite a bit, and I actually saw that this morning. Someone says the stats is not working for them. You have to import it correctly. And I'll certainly will get to that. So there's the stats module inside of SciPy, and inside of the stats module, there's a mstats module, mstats. And inside of there is a specific function called gmean. So if you Google geometric mean Python, you're probably going to get to the gmean function, and that's where it hides. It hides inside of all of these submodules inside of the SciPy package. So it's a bit difficult to get used to. And so what you can see here, one thing that should be clear is that I did not use namespace abbreviation here. I'm importing one of the functions by name. This means when I use it, I don't have to put SciPy dot or whatever. There's no namespace abbreviation here. I can just use that function directly. It's been imported into this Python's namespace directly. So there's a bunch of functions in this mstats module, but I'm just importing one of them directly. And if you do that, you don't have to refer to its whole address, basically where it comes from, the package, the module inside the package is where it comes from. So it's the gmean function, and I'm just going to pass these values, what was it, until 7. And that's going to give me the geometric mean. So once again, please don't be overwhelmed by any of this. This is not to teach you how SciPy and SciPy stats works. That's all coming. All this was an attempt to see, can you go onto Google and find this results? And if you could, that's very, very well done. And what it does behind the scenes, of course, is 3 times 4 times 5 times 6 times 7. And how would we do the 5th root? Well, the 5th root, of course, remember that's to the power 1/5. So there's to the power and 1 divided by 5. I put that in parentheses. So everything in here is in order. And that's how you calculate the geometric mean. And hopefully we're going to get the same answer. Yes, indeed, we do to that approximation. And then the last one, I'm just going to copy and paste, and it's just asking us, is this geometric mean larger than the arithmetical mean? And again, don't worry about it. I'm not expecting you to know this, but there's a numpy.mean function. So numpy, we imported as np dot, there's a mean function. And now I can just pass this list of values 3, 4, 5, 6, 7. Don't worry about this. We're going to learn how to do this. I'm asking, is the geometric mean larger than the arithmetical mean? Just using a conditional there. And we should see there that it's false, because the mean of 3, 4, 5, 6, and 7 is 5. Add them all up, divide by 5 should give me 5, and certainly 4.789 is not larger than 5. So we see that return of false. So I just want to open on my side the chat there.
Jan, at the same time, could you maximize your screen? I think somebody's asking for you to maximize the screen. Thanks.
We already increased the screen size there, but I think, yeah, from tomorrow I'll do even bigger fonts. Okay, but that's the end of what I wanted to say now. I think I remember, I just want to put my hand up and say, the first time I saw this kind of bit of Python code, I was overwhelmed. And I thought, well, I must say there was already just that little, and I think most of you will feel it, just that if you've never seen code before, just that little tinkle in the back of your head. Oh, there's something here. Oh, yes, this is going to lead somewhere. And that's the little tinkle that will very quickly make you put in the effort so that you can speak this language at least slightly fluently, because I think that's where most of us get to, is just slightly fluently. It is overwhelming when you see it the first time, and then certainly to translate this little bit into actual data science and analyzing some data is another step still, but it's a quite exciting step. And all of this, what you've seen here now, don't try and memorize any of this. Trying to memorize this is just it's just wrong. It is about sitting down. And for me, it was like a little child in a piece of sand with my toys and building blocks. Not that I can exactly remember how that happened, but I can well imagine through various home videos and TV shows and movies. No, that's how we learn. You sit in this little sandbox and you play, and that's the only way to pick it up. Okay. Let's see if I can find, I'm just going to stop sharing the screen unless someone wants me to do something specific. So Kanchu, Emil, how many times did you talk about in the sessions about searching for results online, searching for solutions and answers online?
Multiple times I sent links to people instead of answering because hoping that you can just try and Google yourself.
Google is absolutely your friend. Python, NumPy, geometric mean. Let's see what comes up. It's just that in my line, I've used the geometric mean many times. The first thing that comes up, of course, is Stack Overflow. One thing that I always do, because the language changes and the packages are updated, I always go to Tools. And if you hit Tools there, I hope I'm just going to increase my screen size. I hope that's okay. So you hit Tools on the right-hand side, and I go to any time and I say past year. Because there's nothing more annoying than seeing results from 2013. And they're just not going to work. Well, some of them do. I'm being a bit harsh. But that's just something, I don't know if either of you had spoken about that. But for me, it's just a thing to do, tools in past year. Because you really want to see, if you keep your software up to date, you really want to see what the results are, what they are today, not what the code was like a while ago. And some of these results that I see popping up here, pandas. Pandas is going to be your very best friend by come Friday. Pandas is just the grandparent of data packages, and I'm going to spend quite some time and introduce you to pandas. And then, yeah, this tab for me is still open. A place that you can quickly find some lectures on many things. Remember, just go to my YouTube channel. I upload quite a bit, and I suppose any lectures that we make following this, particularly to all the questions that gets asked here, I'm of course going to put right up here on my YouTube channel. So subscribe there and hit that notification bell. I think that's what YouTubers say. And then you can be notified when new videos are released. Great stuff. Should I say it was all recorded? On my side, it says recorded.
Yeah, my side also says it's being recorded.
Oh, someone say got the sorry, Neil. Someone says they got the tingle. I'm so, you know, I sometimes I put these open source lectures out there, and you know, there's this one person who answers, "Oh, this meant so much to me. I got it now." And then you do it for that one person. It's brilliant to see. I'm so happy to see that you got that tingle. Excellent.
Yeah, someone was saying that they're very happy that they're finally can learn a language that doesn't destroy them like C++.
Yeah, C++ can destroy your soul. It is the truth. If anyone is interested, and certainly the language that is pretty much taking over from that is called Julia, and you'll find a lot of my course videos there on Julia. I also have a massive open online course on Julia for scientific computing on Coursera. Maybe Kanshu can link that up somewhere. Julia looks almost exactly like Python. For those of you who don't know about Julia, it comes from MIT. It's been going for a couple of years now, and that community is growing enormously, and it looks almost exactly like Python. If you can code in Python, you can code in Julia. The thing about Julia, it uses a LLVM, a low-level virtual machine, which pre-compiles your code just before execution, which means it runs basically as fast as C and C++. You get all that advantage, and it looks almost exactly like Python. So certainly, if you're looking for another language, not to destroy your soul, but it's certainly becoming much more important than C++ or C, it's definitely Julia.
So I've put a link to the Coursera in the chat room. Of course, it's going to disappear as people type.
Yeah, sure.
I just also want you to, something I didn't mention earlier. Jean's got a couple of courses on Coursera, some of the most widely, sought after courses on Coursera. So we are very lucky to have him teach us Python here.
It's a pleasure for me to do this. It's to everyone who's still listening, and we see all the participants still logged on. This is all about empowerment. I look forward to, and I'm sure we're keeping a list, I'm looking forward to you know, a year or 2 years from now to see what everyone has done, because this is just this idea of growing this community of people with the ability to analyze data, to work with data, to find solutions, that moves us forward. And I think one of the big driving forces of the success of possible future success of humanity is us getting involved, or many of us getting involved in data science. It's just an absolute beautiful thing to behold, and for me, a proud thing to be part of, just my tiny little bit in on the education side as well, to make that effort and introduce people to this wonderful world.
Yeah, and it's also very nice to have a background in code, because we have many times coders are asked to perform magic because the people that are asking them to do it don't understand what code is. And so just to understand how it works and how it's structured and what it can do is going to help a lot in your business one day, even if you're not the coder itself, but maybe you will be the coder.
Absolutely, it's becoming a very necessary skill. I think luminaries, important people all around the world, in many industries talk to that. Just this ability of all of us to understand code, even if you say, Emil, not the one who finally writes the code, but to understand, to have this. And that's why Conchu has that name in our title, isn't it? The School for Data Science and Computational Thinking. It's that idea of computational thinking, at least knowing what lies behind that data analysis or that piece of that answer, which stands most of us in good stead, no matter what industry we go in and what kind of jobs we do find. Very powerful knowledge to have.
So a lot of questions on the recordings. We will send links out, I'm guessing, or are you gonna post it on YouTube? We will send the links out, I think.
I have to see what's the best way to post it. Maybe it'll be on YouTube or it'll be on our on the school's website, but I'll send out links later. Please have some patience. I've got some other work to complete as well. And then I'll post it.
Thanks, Conchu.
But yeah, the recordings will be sent out to everyone, so please just be patient and don't stress.
One thing that was asked there about the data, I'm going to show you exactly how to import data, whether it is most of the time data on your Google Drive, but you can certainly import that from many other places. So we'll certainly get to that. And then thanks for that little heart that popped up there. What I can say is tell everyone about what you learned today. Spread the word. Go and teach someone else. Go and show someone else that all of this exists. Make them aware of the fact. This is pretty much one of those, or I can't remember what the exact term is, passing it forward, isn't it? So whatever you learn here, pass it on to someone else. Tell them, of course, you got it here at Stellenbosch University. But I think as far as this data school is concerned, at least, we really aim to be the center of data science in the country and on the continent, and certainly very thankful to be part of that drive.
Thank you.
Okay, and we see the numbers were great today. For those of you, before you sign off, come back tomorrow. You know, do a little bit of it, start something, and come back tomorrow.
So come back tomorrow, and this should be the same link as today, so you shouldn't have to register, but you do have to log into Zoom every time you come. You then click on the webinar link. That's one. Number two, there are a lot of people here who are students or people who are in the working environment who want to become a data scientist. So what I'm going to do is I'm going to ask one of my former students to come and give a webinar on Thursday afternoon after the lecture. It could be at 4 o'clock or 5 o'clock or 6 o'clock when he's available, to talk about his path to data science. And he will talk about some of the competitions he's taken part in on Zindi, on Kaggle, and he actually won a couple of competitions. He could speak about that too. So if you are available to come to that webinar, please do so. I will send out a link in due time, but it's not compulsory for the certificate.
I've found situations like that so inspiring, Conchu, just to hear other people's journey along this way. It's very, it can be a very powerful thing. Thanks for organizing that.
No problem. No, thank you. Thanks, everyone. Should we stick around for a couple of, me and Emil can stick around for a couple of questions.
One last thing from Johan is just which lectures are for tomorrow? Is it, I think, 4, 5, and 6?
Yeah. So if you go to the schedule itself, it definitely is there for everyone who's still around. It is there on the schedule, and then on the introduction YouTube video, you'll see also there for Tuesday. So we've marked importing and manipulating data, descriptive statistics, and data visualization.
I'm just busy answering question on the Q&A part.
Tomorrow, a similar thing will happen as today. There just won't be a morning session. There will just be an afternoon session where Dr. Yuan will again go through the lectures 4, 5, and 6, but do go through them yourself beforehand and then come to that session.
There's no register. Don't worry, I have the register. I looked through the list of people and I have it in my memory. Zoom takes register.
Was just going to compliment there on the prodigious neurons that you got going.
The assessments would be after the Friday lecture during the weekend or something. It'll be, we'll give you some time to do it. It won't be like time for an hour or something like that.
No, and it won't be onerous at all. This is to get you excited, to get you going, not to be any kind of punishment or drag.
So let me answer Moses' question. And Moses, I'll speak about it a little bit more on Thursday when we have that webinar as well. So the school, the university has two main undergraduate programs. So one is the Bachelor of Data Science and the other one is the Bachelor of Engineering in Data Engineering. And of course, we have the normal, programs that's always been offered, which are like Bachelor of Commerce and Information Systems, Bachelor of Science, Computer Science, Mathematics, Applied Mathematics, Statistics, etc. So there are a range of programs that one could take at undergraduate level to learn data science or data science related subjects. At the postgraduate level, we have a postgraduate diploma and a master's in industrial engineering specializing in data science. We have, of course, masters in computer science, in statistics, in information science or information systems. Bruce can tell me which one it is. We have masters in bioinformatics, etc. A range of subjects which you can specialize in a niche field of data science. But if you wanted more general one, I would say it would be the industrial engineering program. Moses, I hope I have answered your question. If you look on our website, you will see there's a link to academics. Under academics, there's some postgraduate list.
Someone asked if there's an honors degree.
Sorry, can you say that again? Emil? Okay. I hope my. Okay, can everyone hear me?
Yep.
So the Bachelor of Data Science requires, I forgot, it's either 70% or 80% in maths. I believe it's 80%. If you go to the link on our web page, it will tell you what that mark should be to enter the data science program. How do you advise someone to bridge the gap? The best way to bridge the gap is to ensure you do well in your matric maths, retake your matric maths if you have to, or if you don't get in the Bachelor of Data Science program, you can always do a related program and then do a postgraduate diploma in data science or through another route as well, right? So anonymous attendee, I hope I have answered your question.
Which always is a fair question to ask. In the mathematics, I think in many fields, I know in the healthcare sciences, it keeps many people out of data science, this fear of the mathematics. My personal journey, of course, came via the love of mathematics, and that's why I have so many video lectures on math. But I think once you're interested in data science, the mathematics that is required for that becomes a lot more interesting too. It is another way to start enjoying the mathematics that you might not have enjoyed before. as I said, I think, yeah, it is an advantage if you came via the love of mathematics into the field, which was really my journey. But the mathematics almost comes alive, I think, in many instances, and so don't shy away or let that be in any form or an impediment to your want to get into data science.
Yeah. Is there an honors degree for data science at Stellies? So we have a 4-year Bachelor of Data Science degree. We have a 4-year Bachelor of Engineering in Data Engineering. If you want a pure honors degree, there's a BCom and a BSc in Statistics or honors in Statistics. We have honors in Computer Science, Information Science, I believe. We have honors in Bioinformatics. There's definitely a range of honors one could take here at Stellenbosch University. Honors in Applied Math, and we are offering from next year Masters in Machine Learning and Artificial Intelligence as well. I forgot to mention that. What would you recommend as the initial study program for a medical doctor? I see Jan is typing in profusely over there.
No, I'm not typing profusely. I was wanting a bit more information as to what that question is, because there's obviously a lot of information hidden in
yeah, it was crazy. I presume you are a medical doctor already. And it'll be good to hear what you'd like to do if you're already a medical doctor, what you'd like to do with data science. One can go into epidemiology, one could go into bioinformatics. We have one of the world's best bioinformaticians here at Stellenbosch University. He started in July of this year. If you Google his name, Tulio de Oliveira, you'll find lots of things about him. He's on the phone to the president every day because he answers questions on COVID and the new variants that we are seeing all over the world, and particularly in Africa. So there's lots of things a medical doctor could do, but Jan is right. It is good to know what exactly you mean, further. To go to data science route, can one take maths or stats with computer science, or either is okay? Either is really okay, because in your degree, whether you major in maths or stats, you'll do at a lower level. So even if you do maths 3, you'll do at least stats 1 or stats 2, or if you do stats 3, you'll do maths 1 or maths 2. So you'll get enough in there. It's impossible to take, of course, all the majors there is. %, matric maths to get into Bachelor of Data Science degree and into Bachelor of Engineering, Data Engineering. I believe, please do check our website because I don't know that offhand. What do we end up using coding for? You end up using coding for many things, right? So one, simply the Zoom platform that you're using to communicate to me, that was coded using some software or some language. The coding that we are learning here in this course is largely, data science related coding, where we use Python to analyze data. Right? So anything that any application you use on your phone or on a computer, or even some of the applications in a car, etc., are coded using some computer program. Is it possible to do an MSc in bioinformatics with BSc in information technology? I would say after the BSc in information technology, you should do a BSc honors in bioinformatics and then do a MSc in bioinformatics. And I truly believe that Stellenbosch University is one of the most exciting places in the world to do bioinformatics at the moment. I wish I was in bioinformatics to take part in that excitement. We don't have an online master's in data science. We have full-time masters in industrial engineering, specializing in data science, but you can do a full dissertation master's. It wouldn't say masters of data science. It could say masters in stats or masters in information science, etc. But your project, your full dissertation would be on a data science related project. If you're interested in something like that, do email me or do email Bruce Watson or somebody at the school. You will get more information there. You're welcome to Aspire. I'm glad you are able to join. I'm currently studying at UKZ and doing a degree in BSc in data science. Would a BSc in data science differ from UKZ and Stellies? So every university will have its own difference. That doesn't mean the one would be better than the other. Our degree here is Bachelor of Data Science rather than Bachelor of Science in Data Science. So it's a 4-year degree. where you finish with an honors, equivalent of an honors in data science. Yeah. Hope I've answered your question. Oh, Beatrice, the easiest way is to, after you've done your degree, depending on whether you've got an honors or an undergraduate degree, you then do a postgraduate diploma in data science, or you could do a master's in data science. Actually, it's quite easy to move from chemistry, physics, biotech into data science because of you would have had a good math background.
Couple of questions on machine learning and, sorry.
Pardon?
Couple of questions on machine learning and robotics. So obviously it is very related to data science itself, but then for more of the machine side, you'd have to approach electrical engineering or computer science for machine learning as well. And then they also have masters and PhDs and postgrads and all that stuff.
And robotics is especially, I would say, at electrical and electronic engineering or mechatronics, right?
Yeah, well, you can do both.
And the applied math department together with the computer science department is offering a master's in machine learning and artificial intelligence. So do keep a lookout for that. Is there a route for accounting majors to pivot after graduation, even though they do not do statistics after first year? I would say look at the postgraduate diploma, the requirements to enter it. Look at our master's program to see what are the prerequisites to enter it. And then you do the extra courses, which I don't think will be a lot during your undergraduate or just after your undergraduate. So for the last 9 years before last year, I used to teach finance and accounting students before I came to this role here. So definitely there's a role for accounting students to move into data science, and you'll find that as technology gets better and as the models get better, there's a lot of things that we can do with data science in the accounting space, particularly in auditing, right? Where we can check for audit irregularities quite easily using data science methods. How about doing MSc in machine learning within BSc information technology? So to do a master's, you definitely need an honors degree first rather than a 3-year degree. So think about what the right honors degree would be to get into the MSc in machine learning. Look at the prerequisite for the MSc in machine learning and just make sure whatever honors degree you do gives that prerequisite. It might be that the honors degree, the master's degree in machine learning and artificial intelligence at SU requires an honors in applied math or a computer science, but I might be wrong. Yeah, I'm trying to answer these as quick as I can. Does the data science course cover industry-related topics? I'm in credit risk banking. Kanyam Koto, so that is my specialty, is in credit risk banking. At the moment, we have a PhD student who's doing credit risk. We have a financial risk management master's program here at Stellenbosch University. Data science lends itself to credit risk quite easily. In fact, it probably lends itself to credit risk than any other parts of the bank. So definitely the answer is yes.
Someone asked if machines can be coded by Python. So most of machine learning today, or at least new age AI, is done through Python and TensorFlow and that kind of stuff. But then also R and some of the older languages are also used, but very much Python, because of all the packages that you get in one single language, is majority used for machine learning at the moment.
Yes, and then as we mentioned, this
financial economics, I'm wondering what path I can pursue in line with data science. So if you're doing financial economics, you could do a postgraduate diploma or a master's in data science, in industrial engineering, I believe, as long as you've got the math prerequisite. If you do well in your econometrics course, that also proves that you're capable of doing mathematics. You can also look at the Masters in Financial Risk Management, which has, I think, some data science courses in it. Of course, in answering these questions, I'm answering you from a Stellenbosch University perspective because I only know our degrees here, right? I'm doing my final year in investments and finance and investments. I presume you're at Stellenbosch University or UJ. Is there a way of merging data science with financial analysis? Absolutely. Data science lends itself to financial analysis. In fact, if you look at the courses that we're offering later this year, there is a course in data science for algorithmic trading strategies, which is going to be offered by a gentleman a professor who is a professor in New Jersey in the US. So there are definitely applications of data science in the finance world. What are the requirements for postgraduate diploma if coming from a non-STEM undergrad? So I would say go look at our website, go into the link on academics, look at the prerequisites for the postgraduate diploma. There should be a link which opens up that will tell you all the prerequisites, and then think about how can you get those prerequisites to enter the postgraduate diploma. Of course, you could study some of those prerequisites through UNISA or a university near you. Until you have the prerequisite. Also, Stellenbosch University isn't the only place that offers postgraduate diploma. I'm sure other universities as well. I just don't know which ones they are. If I've acquired an honors in physics or any physics-related fields such as astrophysics, do I qualify to do master in data science at Stellenbosch University? I presume you would, because you would have a good math background. But the best is to go look at our website and see if you have all the prerequisites. I'm pretty sure somebody with the honors in physics should have the prerequisites to enter a master's program in data science. Woo, done. Okay, everyone, can I close off for today?
Yes, thank you very much for all of that. I think you've made many people aware of all the fantastic things that are available at Stellenbosch University. And I think hopefully this leads through to a lot of exciting things. Thank you so much.
Cool, thank you. Zwake, last question. I presume you can do a correspondence course in data science through UNISA. I don't know any other place that might offer it. Thank you, everyone. See you tomorrow.
Thank you.
I'll put up the recording as soon as I can. Sorry, Emil.
Just saying thank you. Yep, see you guys tomorrow. Have a good evening.
See you.